Question 2e, Part 1. Express cos x minus sin x in the form r cos x plus alpha, where alpha is in radians. Expanding r cos x plus alpha using a compound angle expansion, we get r multiplied by cos x cos alpha minus sin x sin alpha. And expanding the brackets, that equals r cos alpha cos x minus r sin alpha sin x. Now this is identical to cos x minus sin x. So writing all that as an identity, we have cos x minus sin x is identical to r cos alpha cos x minus r sin alpha sin x. Now the coefficient of cos x on the left hand side equals 1, which must equal the coefficient of cos x on the right hand side. So r cos alpha must equal 1 and negative r sin alpha must equal negative 1. So by equating coefficients, we form these two equations. R cos alpha equals 1, we'll call that equation 1, and r sin alpha equals 1, and we'll call that equation number 2. Now solving equations 1 and 2 simultaneously for r and alpha, if we take both equations, square them and add them together, that'll eliminate the terms involving cos alpha and sin alpha. So r squared cos squared alpha equals 1, r squared sin squared alpha equals 1. So adding these two equations together, we get r squared outside of cos squared alpha plus sin squared alpha, since r squared is a common factor, and that equals 1 plus 1, which equals 2. And using a Pythagorean identity, cos squared alpha plus sin squared alpha equals 1. So we end up with r squared is equal to 2, taking the positive square root of both sides. Since r represents an amplitude, we have r is equal to the square root of 2. Next, to find alpha, we can take equation number 2 and divide it by equation number 1. So we have r sin alpha over r cos alpha equals 1. The two r's cancel, we end up with sin alpha over cos alpha, which equals tan alpha. So this forms the equation tan alpha equals 1. And taking the inverse tan of both sides to make alpha the subject of the formula, we get alpha is equal to pi over 4. Therefore, cos x minus sin x is identical to the square root of 2 times cos of x plus pi over 4. Part 2. Hence, or otherwise, sketch the graph of y equals cos x minus sin x for x greater than or equal to 0 and less than or equal to 2 pi. The graph of y equals cos x minus sin x is identical to the graph of y equals square root of 2 cos of x plus pi over 4. And this is from part 1. Now this is a cosine curve with an amplitude square root of 2, period 2 pi, and a phase shift pi over 4 to the left. Here is a sketch of the curve y equals cos x minus sin x, which is identical to the curve y equals the square root of 2 cos of x plus pi over 4. It has a y-intercept of 1. The curve ends at this point, which is at 2 pi comma 1. It has x-intercepts at pi over 4 and 5 pi over 4. The minimum point occurs here at 3 pi over 4 comma negative square root of 2. And the maximum value occurs here at 7 pi over 4 comma square root of 2.